Hello champs, welcome to Decagon Math, where math is made easy. Today we are diving into another aspect of complex number, which is conjugates of complex numbers. So before we define conjugate of complex number, let's quickly be reminded of what complex number is. So we know that z being a complex number is equals to a plus ib. And we know that A is the real part, I is the imaginary unit, and B is the imaginary part, right? So having said that, now let's define the conjugate of a complex number. So let Z be a complex number then Z bar is said to be the you have the conjugate of Z if Z multiplied by Z bar is equals to a real number. So what we are saying is that if the product of Z and Z bar gives a real number, then that's when we have that this Z prime is a conjugate of Z. So that's what we are saying. Alright. So now let's Z equals to A plus IB. Then what will the conjugate Z bar be? Then the conjugate Z bar will just be another complex number, which will be A minus IB. Now you observe that to obtain the conjugate of this complex number Z, A plus IB, we just change the positive to negative. So that's just how you find the conjugate of a complex number. Just change the positive to negative. Or if the complex number is A minus IB, then the conjugate will be A plus IB. So just change the sign. Alright. Now let's multiply these two complex numbers and let's see if it will give us to a real number, as we have said. So we have that Z1 multiplied by Z2 equals to A plus IB multiplied by A minus IB. Alright. So this equals to A into bracket we have A minus IB then plus IB the bracket A minus IB. Alright, so what we just did there is that A here multiplies all the A minus IB here, while IB here multiplies all the A minus IB here. So that's what we have done here, right? So now let's multiply this out. So multiply this out. This equals to A multiplied by A gives A square, and then A multiplied by minus IB gives minus IAB. And then move on to the next one, which is this. So IB multiplied by A gives plus IAB, while IB again multiplied by minus IB gives minus I square. We have I squared B squared. Alright, so it's obvious that this cancels out this, so we are left with a squared minus I squared b squared by this. And recall that I squared is equals to minus 1. Remember this. So then we're going to fix it here. So here we have that this equals to a square minus, in bracket, this one is minus 1 because I square, because I square is now minus 1, so then b square comes here, so we write b raised to power 2. So from here, minus times minus gives positive, so we have a raised to power 2 plus b square. So we have that z multiplied by z prime is equals to a squared plus b squared. Right? So a squared plus b squared is a real number. It's a real number because we have no I, which is the imaginary unit. We have no I here. So it gives us to a real number. Now we shall be given the conjugate of some complex numbers, and we shall show that their product gives a real number. So to serve as example, we'll be looking into some complex number that will be given now, and we will find their conjugate and check if they give rise to a real number. So the first one that we have here, we have z1 is equals to 3 minus 2i. Alright, so according to what we have said, what changes here to find the conjugate is just this minus, and it changes to plus. So let's name the conjugate as z1 bar, which will be 3 plus 2i. So let's multiply it. We have z1 multiplied by z1 bar equals to, we have 3 minus 2i multiplied by 3 plus 2i. Okay, so this equals to 3 multiplies all of this, so that is 3 into bracket 3 plus 2i, and then 2i multiply all of this also, so we have minus 2i multiplying 3 plus 2i. Okay, so 3 multiplied by 3 is equals to 9, and again 3 multiplied by plus 2i gives plus 6i. Now we move on to this part. So minus 2i multiplied by 3 gives minus 6i, while minus 2i again multiplied by 2i gives minus 4i squared. So obviously this cancels this out. So now we are left with just 9 minus 4i squared. So recall that I squared is equals to minus 1. So we are going to replace this I squared with minus 1. So in the next line we have 9 minus 4 the bracket minus 1. Then we have that 9 plus 4, because minus times minus is positive. So, and z z1, sorry, so we have that z1 multiplied by z1 bar is equals to 13, right? And 13 is a real number. So we have seen that a complex number multiplied by its conjugate gives rise to a real number, right? Okay, let's have the second example, number 2. Let's have that z2 is equals to minus 5 plus 8i. So having this, so let's have our conjugate to be z2 bar to be defined as minus 5. So can you think of what changes here? Again, this positive changes to negative, right? As I have said that we are going to negate this sign. So you have negative 8i. Notice that the sign here, which is negative, does not change, right? It's only the one here, the one in between the the real part and the imaginary part. So that is the sign that's going to change. So plus will be the one to change to negative here. This minus is not changing. Only this sign here changes to this one here. So let's multiply what we have. So z1 multiplied by z2 bar equals to, we have minus 5 plus 8i multiplied by, we have multiplied by minus 5 minus 8i. Now this equals to minus 5 so we have minus 5 multiplies all of this. So minus 5 into brackets minus 5 minus 8i multiplied by, we have plus 8i multiplied by minus 5 minus 8i here again. So moving on. Now minus 5 multiplied by minus 5, minus times minus is plus, so we have a plus 25. I can just write 25 like that, and then minus 5 will multiply minus 8i, which gives a positive 40i, because negative times negative is a positive, right? So then we'll move on to this part. 8i multiplied by minus 5, we have minus 40i. Then we have 8i, we multiply minus 8i, that gives positive. A positive times a negative is a negative, and then 8i multiplied by 8i we give, that is 64i squared. Alright, so 40i cancels out minus 40i, so you are left with 25. You are left with 25 and minus 64i squared minus 64i squared, right? So again, recall that I squared is equals to minus 1. So we have that this equals to 25 minus 64 bracket minus 1. So this equals to 25 plus 64. And 25 plus 64 gives 89. Again, 89 is a real number, right? Now we're moving to number 3. Number 3. So we have number 3 to be z3 equals to minus 7i Alright, so the conjugate of this will be written as z3 bar, which will equals to, now you know this can be written as 0 minus 7i, right? So you can see that the sign in between it is minus. So then this implies that z3 bar, which is the conjugate of this, will now be 0 plus 7i. Alright, and then let's multiply. We have that z3 multiplied by z bar of 3 equals to, you can simply write minus 7i multiplied by 7i. You can just write that, because the 0 is, you can ignore it. So minus times plus is a minus. 7 times 7 is 49, and I times I is I squared. So this equals to minus 49 the bracket minus 1, because I squared is minus 1. So minus times minus is a positive, so we just have 49. Again, 49 is a real number, right? Now let's move on to the last example, which is number 4. We have that if we have that z1, if z1 is equals to 3 minus 2i, and z2 equals to minus 7i. So we have to find z1 plus z2, the conjugate. So this line means conjugate, so you have to find the conjugate of z1 plus z2. So firstly, we have to find z1 plus z2. So z1 plus z2 equals to, now z1 is 3 minus 2i. It is 3 minus 2i. So we have 3 minus 2i plus z2 which is minus 7i. So that's minus 7i. Alright, so when we expand the brackets, we have 3 minus 2i minus 7i. So we have 3 minus 9i, because minus 2i minus 7i gives minus 9i. So now you can now find the conjugate of 3 minus 9i. So the conjugate of 3 minus 9i, so let's say we call this z4. So you can say that the conjugate of z4, we write it as z4 bar, which equals to 3 plus 9i, right? Because just change the sign here to positive. So this implies that when you multiply z4 and z4 bar, this is equals to 3 minus 9i. We multiply it by 3 plus 9i. So this equals to 3 into bracket 3 plus 9i. Then we have minus 9. We have minus 9i. We multiply 3 plus 9i. So we have minus 9i. We multiply 3 plus 9i. So let's multiply this out. We have 3 times 3 is a 9, and 3 times plus 9i is a plus 27. So we have plus 27i, and then move on to the next part, which is this. We have minus 9i multiplied by 3 gives a minus 27i, and then we have minus 9i multiplied by 9i gives minus 81i squared. Let me write this well. Minus 81i squared. Alright. So we know that this cancels this. Then we are left with 9 minus 81i squared. And we know that I squared is equals to minus 1. So this implies that we have 9 minus 81 bracket minus 1. So minus times minus is a positive, so we have 9 plus 81, so which equals to 90. 90 again is a real number. So far we have been able to show that a conjugate multiply a complex number multiplied by its conjugate gives a real number, right? Okay. So we have a remark here. Alright. So we have a quick remark here. So what is our remark? Our remark is that if z equals to a plus ib, then the product of z and its conjugates, which we know that would be z bar, will be, so the product will just be z multiplied by, I think you know that dot simply means multiplication. So let me write the dot properly. Let me write this. So we have that z multiplied by z prime will just be a square plus b square. So that means if we have it means that if you have z, a complex number z, which is a plus ib, then the product of this z and its conjugate z prime will just be a square plus b square. And if you observe for everything that we have been doing, that's what it is, right? So look at this one, this number 3 now. We have that what we have is, our result is 3. Let's scroll up. Okay, this, let's have it here. Okay, the sum, which is this z4 is 3 minus 9i. So this is our a, 3, and our b is, let's say, minus 9, right? So you can see that the result of the complex number and the conjugate is just saying 3 square plus the square of minus 9, which is 9 plus 81, and which gives 90, right? and it's also true for every other one that we have done. So very quickly, I want to ask you this: if z equals to 6 minus 4i, then what will be the product of z and its conjugates? So 1, 2, 3, 4. Okay, so the answer is what? So the answer is 52, right? So we don't need to actually write the conjugates and start multiplying before we can know that, since we already said that the product of z and its conjugate will just be what we have here, 6 square plus the square of minus 4. So that means 6 square equals to 36, and minus 4 square is equals to 16. So 16 plus 36 gives 52, right? Should be our answer. So we have come to the end of this lesson. If you have watched to this moment, that's great. Remember, keep practicing, and remember, the more you solve, the more confident you become. So don't forget to like, share, subscribe, or follow Decagon Math for more educational content. So see you next time, guys. Goodbye.